Hello and welcome back to our series, Build a Robot from Scratch. This is episode 3, and today is a huge milestone. We're going to build the robot's physical body and wire up all the core components. It's going to be a detailed, step-by-step process, so grab your parts, and let's get building. A quick but very important reminder: follow each step carefully and never, ever connect the battery or power up the system until I give the final instruction. Safety is always our #1 priority. Alright, let's begin with step 1, preparing your workspace. You'll want a large, clear, flat surface to work on. It's a great idea to have a few small containers handy for all those little screws and nuts so they don't roll away. Gather your tools: a screwdriver set, a small wrench or pliers, a wire stripper, a multimeter, some double-sided tape, zip ties, and a soldering iron if you have one. And I'll say it again, make sure your battery is completely disconnected and set aside for now. Now for step 2, mounting the motors. Take your robot chassis and place it so the front is facing away from you. This helps keep the left and right sides consistent. Go ahead and attach the left and right motors into their designated brackets on the chassis. You'll need to align the motor shafts so they poke through the holes in the frame. Secure them with M3 screws. You want them to be snug, but be careful not to over-tighten, especially if you're screwing into plastic parts, as you could strip the threads. If your kit uses zip tie mounts, just pull them tight and snip off the extra length. Step 3 is all about the wheels. Gently but firmly push each wheel hub onto its corresponding motor shaft. Some wheels use a small set screw to lock them in place. If yours do, use a hex key to tighten it just enough to hold the wheel securely. Once they're on, give both wheels a spin with your hand. They should rotate smoothly and freely without any wobble or rubbing against the chassis. If there's any friction, now is the time to fix it. Next up, step 4, adding the caster or support wheel. This little wheel provides balance and allows your robot to turn smoothly. Depending on your chassis design, you'll mount it at either the back or the front center. Use the spacers and screws that came with your kit to attach it. The goal here is to make sure the robot sits perfectly level on the ground. You don't want it tilting forward or backward. With the mechanical assembly mostly done, let's move to step 5, placing the electronics. Grab your Arduino and your motor driver board. We're going to mount these onto the main chassis deck. You can use strong double-sided foam tape or, for a more professional finish, use nylon spacers and screws. This not only keeps them secure but also prevents any electrical shorts against a metal chassis. When placing them, think ahead. Leave some space at the front for our ultrasonic sensor, and make sure the USB port on the Arduino and the screw terminals on the motor driver are easily accessible. You'll thank yourself later. Step 6 is a crucial planning phase, understanding the wiring. Before we connect a single wire, let's review the game plan. The flow of connections will be: first, the motors connect to the motor driver. Then, the motor driver gets power from the battery and control signals from the Arduino. It's essential that all components share a common ground connection. We'll connect the Arduino's ground to the motor driver's ground. Finally, our sensors, like the ultrasonic sensor, will connect directly to the Arduino. This roadmap will make the actual wiring process much smoother. Let's execute that plan, starting with step 7, connecting the motors to the motor driver. Look at your motor driver board. You should see outputs labeled for motor and motor B, often as OUT1, OUT2, OUT3, and OUT4. Connect the 2 wires from your left motor to the OUT1 and OUT2 terminals. Then, connect the 2 wires from your right motor to the OUT3 and OUT4 terminals. Don't worry too much about which wire goes where just yet. If we find out later that a motor is spinning in the wrong direction, we can simply swap its 2 wires to reverse it. It's an easy fix. Moving on to step 8, connecting power to the driver. I must repeat this. Do not connect the battery yet. We are only preparing the connections. Take the wires from your battery connector. Connect the positive wire, usually red, to the terminal on the motor driver labeled motor, VM, or plus. Connect the negative wire, usually black, to the terminal labeled GND. We are just setting up the circuit. The battery itself should remain unplugged until we are completely finished and ready for testing. Step 9 is simple but critically important, creating a common ground. All of our electronic components need a shared reference point to understand the signals being sent between them. To achieve this, take a jumper wire and connect one of the GND pins on your Arduino to the GND terminal on your motor driver board. This single wire ensures that both boards are on the same page electrically. Now for the brains of the operation. Step 10. Arduino signal wiring. This is how the Arduino will tell the motors what to do. We'll use jumper wires to connect specific digital pins on the Arduino to the input pins on the motor driver. Connect Arduino pin 8 to IN 1 on the driver. Pin 9 goes to IN 2. Pin 10 goes to IN 3, and pin 11 goes to IN 4. These control the direction of the motors. To control their speed, we'll connect the PWM-capable pins. Connect Arduino pin 5 to the NA pin, which enables motor A, and pin 6 to the NB pin, which enables motor B. Also, double-check that the logic voltage jumper on your driver is set to 5 volts to match the Arduino. At this point, you probably have a bit of a rat's nest of wires. So, step 11 is all about tidying up. Good cable management isn't just for looks, it's a critical safety measure. Neatly route your wires along the chassis. Use zip ties or small cable clips to bundle them together and keep them away from any moving parts, especially the wheels and motor shafts. A loose wire getting caught in a wheel can cause a short circuit or damage your robot, so take a few minutes to make everything clean and secure. Time for the robot's eyes. Step 12. Mounting the ultrasonic sensor. This HCSR04 sensor will allow your robot to detect obstacles. Mount it right at the front and center of your chassis, making sure it's level and pointing straight ahead. Now for the connections. Connect the pin labeled VCC on the sensor to the 5 volts pin on your Arduino. Connect the GND pin on the sensor to a GND pin on the Arduino. Finally, for the signal pins, connect the trig pin to Arduino pin 12 and the echo pin to Arduino pin 13. For those of you who want to avoid soldering, let's talk about step 13, an optional breadboard setup. A small breadboard can act as a central hub for all your signal connections. You can mount it on your chassis and use it to connect the Arduino pins to the motor driver and sensors. This makes it really easy to change connections or add new components later without any permanent soldering. Just remember to keep the jumper wires as short and neat as possible. And of course, the battery remains disconnected. We're almost there. Step 14 is adding a battery connector and a power switch. This switch is your best friend for safety and convenience. If you're comfortable with soldering, now is the time to connect your battery plug to the power input wires. We are going to install a small switch on the positive, or red, wire between the battery and the motor driver. This gives you a safe and easy way to turn your robot on and off without constantly unplugging the battery. For now, ensure that the switch is in the OFF position. Finally, the last step before we even think about power, step 15, the pre-power multimeter check. This is your final safety inspection. Set your multimeter to continuity mode, the one that beeps. First, check for ground continuity by touching one probe to the Arduino SGND pin and the other to the motor driver SGND terminal. It should beep. Next, check for shorts. Touch the probes to the motor and GND terminals on your driver. It should asterisk not asterisk beep. If it does, you have a short circuit that you must find and fix. Lastly, do a final visual check. Are all screws tight? Are all wires properly insulated and secured? And that's it for part 1 of this episode. Your robot's body is assembled, and all the wiring is laid out and ready to go. You've done an amazing job. In the next video, part 2, we will take the exciting and critical step of powering it on for the very first time. We'll test the motor directions, calibrate the speed, and make sure our ultrasonic sensor is working correctly. Thanks so much for building along with me today. If you found this helpful, Please give the video a thumbs up. And don't forget to subscribe and hit that notification bell so you don't miss the next part. See you soon.